FAISY, who's going to tell us about the energy deficit. He's an expert in that field. Ladies and gentlemen, how can we measure energy deficit, how and why? These are my conflicts of interest. Delta Medical and Fresenius can be for this particular presentation. This is somewhat paradoxical when you look at major events such as famines, shock or renutrition syndrome after wars. Can be summed up by what Émile Zola said in his book La Débâcle, when he talks about French soldiers that have gone without any food for weeks, and he says, well, a lot of them died from it. So that's life. Simple. And about patients in the ICU, there is a controversy regarding how can we limit the energy deficit, what should immunonutrition be, what is the point, what is the relevance, what is the benefit of it, and risks associated to overnutrition. All in all, when looking at nutritional assistance in the ICU, we may wonder whether there is a real impact on morbidity and mortality. One way of approaching this issue is to wonder whether our assessment tools regarding the nutritional status are really adapted to the situation of a patient in the ICU, or are our physiopathological concepts totally wrong, erroneous? When we look at the energy balance, traditionally we look at energy expenditure, taking into consideration baseline metabolism, the thermal effect of nutrients, thermoregulation, muscle activity, and we look at energy stored. For a healthy subject, it's 100,000 kilos of calories, but this is stored energy. Now, we shall look first of all at energy supply or provision. We shall look at, and it's not that easy to quantify it, energy expenditure. We have, in order to measure these tools available in the ICU, indirect calorimetry, predictive equations, and in second stage we'll also talk about energy which is stored and other forms of energy also. But before that, to shake you up a little bit just after your meal, I would suggest that we look at this issue from a slightly different angle. Assessing supplies and provisions is not that simple. This is a graph that goes back quite a few years now, and it shows the ratio, the dotted line, between what doctors are prescribing and what they should prescribe, take into consideration the energy expenditure of the patients that they are taking care of. And we see that roughly we reach a 50% level. And that's the dotted line. And the continuous line is what is really prescribed by nurses, and they can go up to 70% of what is being recommended. So already there's quite a gap between what is actually spent and what is really administered to the patient. Now, why is that? Well, in patients in the ICU, the most critically ill have very often gastrointestinal intolerance. There's the effect of sedation drugs and vasoconstrictive drugs. Very often you have to stop enteral nutrition because of diagnosis needs and therapies. And there's a form of inertia in the medical and paramedical field and lack of knowledge of good practices. And the result is underprescription of enteral nutrition. 2/3 of the time we are in a situation whereby the enteral nutrition is limited as such, and 25% of the time we are in a situation where EN, enteral nutrition, has to be discontinued. Now, there are sources of energy which are non-nutritional, such as glucose infusions. 200 kilocalories is what you will get from algae. 5% and 10% will give you 400 kilocalories. There's peritoneal dialysis, there's continuous hemodiafiltration, and there's sedation using propofol. The result of all this, well, we'll find it in some studies like this one. Here, what you are told is that basically, if you apply the guidelines, you can go up you can feed 1,400 kilocalories to the patient in services that have applied these guidelines. But what you are not told here is what is really being prescribed, not what is on the prescription form, but what the patient actually gets. And here, down here, is the result of a study which is in fact promoting permissive hyponutrition, trophic nutrition. In one group, no calories or hardly 400 calories, and in the other, you don't really have any information as to what they are getting, and not much difference really between what some patients get, which is nothing, and some get hardly anything. So here another study where we see that they've forgotten to take into consideration non-nutritional calories, and there was probably an impact of overnutrition on nosocomial infections for this particular group. So basically, you should have at least signs that will give you an indication so that you can assess the time during which nutrition was discontinued, and also the impact of the gastric residual, because at least for one of these two studies there was quite a very surprising result as to the impact of the gastric residual. Now, looking, by the way, I wanted to mention Lavoisier in 1794. He said life is a slow combustion maintained by breathing. Animals are made up of combustible elements, and feeding replaces loss of substances resulting from the combustion of some matters present in the organism. He got his head cut off, by the way. He was a taxman, so that probably had a lot to do with the decision. But he had understood everything 250 years ago. Basically, what is energy? It's a property of matter, whether it's inert here or whether it's live, the lower part of this graph. And matter, in fact, is in fact what is the difference between the inert matter and living matter? It has to do with the level of energy that can be used. It's the principle of entropy. It goes up as time goes by within the universe. The universe is a closed system from the thermodynamic standpoint. And the paradox of life is that in living systems, this level of entropy goes down. You are alive, you produce negative entropy, and this is what makes you different from inert matter. And the level of energy that you can use, that is available to you, is therefore higher. How is that possible? It's because the system is alive and that we have open systems. And if we look at these systems, well, we call them dissipative systems. There's a flow of energy or matter that goes through these systems, and they self-organize themselves, and they increase the level of entropy which is available. And basically, you come up with what we call a dissipative system, whereby information is accumulated and energy is being used. And if you look at this graph, you see the time scale here is the universe scale. How can a living matter can be self-organized? Well, you see it here, and you see the flow of energy along this axis. You can compare 1 gram of the human brain it will dissipate 50,000 times more more energy than a gram of solar matter. Just to give you an idea of what this means. This is, by the way, Prigogine, who produced that. He's a Nobel Prize of Physics. He's not some sort of crazy scientist, but this is all very serious. Now, going back to the level of the cell, what will this dissipative system result in? What will it produce? This is interesting for us because it helps us understand the limits of limitations of our systems. We have processes here that are involved: anabolism, catabolism, communication with the nervous system, evolution, immunity, and everything which is contained in the cell. And you have different structures, different elements, carbon, oxygen, etc. For heterostasis, you have what will determine the form of a cell, electrochemical gradients. This is called heterostasis. And finally, everything related to immunity, evolution, and this is what we call teleostasis. So, with our modest tools, and we think they are very sophisticated, but in fact, what do we do? What do we use them for? Basically, we focus on that area and forget about the others. And of course, you understand immediately that we do have a problem because of that. So what is indirect calorimetry? It's basically our benchmark method. It measures the oxygen consumption, the production of CO2, because the hydrolysis of nutrients, the oxidation of nutrients, the composition, and then the synthesis of ATP represents this flow of energy produced by our metabolism. And with the indirect calorimetry, we can also measure energy as heat. It's another form of energy, but it's still energy. And the problem is that you're only exploring basically what's happening on the left-hand side and forgetting about the other two, the left-hand side column. So it's our reference method or benchmark method, but literature doesn't tell you everything, and there are limitations. This is a non-exhaustive list of indirect calorimetry aspects in patients in the ICU, and you see in ventilated patients, and half the cases, or one-third of the cases, measures you get or levels you get from indirect calorimetry, these figures are wrong. There are very few studies that will give you these criteria, these quality indices, and it's a problem because for the subsequent validation of the methods that enable you to compute the energy that has been spent, you will have a problem because, in fact, you have not said that in one-third up to half of the cases, these results are wrong. They are not valid. Basically, it's the benchmark method in the ICU with all the limitations I've told you about. It's limited to the most critically ill patients. You need criteria to assess the quality of these measurements, but basically they are never available or to be found in the literature which is published. It requires expertise and time. It's not available for each critically ill patient, and it's very expensive, 30 to 40,000 euros to get something like that. I'd like to have one, but I can't afford it. Apart from that, what else do we have in our box, in our toolbox? We have predictive equations. Here we are on sure ground. We have the Harris-Benedict equations, but these are not reliable in the ICU, so we are left with modern multi-parametric equations. They are more reliable. However, The downside is that their accuracy will be dependent on circumstances, and when you compare them with calorimetry values, these are not reliable. So how can you compare something with something which in turn is not reliable? So it's a bit of a vicious circle. Goals are recommended by learned societies. For the French-speaking community, these goals have been slightly modified in 2014, 2025 kilocalories per day, and then once the patient stabilized, a bit more. A bit like the European American recommendations, but it doesn't take into account the variability of the DRE in the ICU and the problem of weight and obese patients. You then should use the adjusted weight. Here's a formula. It's easy to calculate, but these do not necessarily mean that you're going to strictly abide by the protocol. So as regards estimating expenditure, assessing expenditure, here I have 3 examples from the literature. The top example, when you look at how the energy expenditure is assessed in much talked about article in 2011, we are very, very surprised when we see this. This is why I put a red light. And then here, multi-parametric study with the orange light, because I have strong reservations about the methods that have been used, and something more recent in the Lancet 2013 using indirect calorimetry, a green light, but with a question mark, because there are no quality criteria here, albeit every time authors will tell you, yes, we did go abide by the various criteria, limitations, etc. It's not sufficient. So let's look now at other forms of energy, because the result is not satisfactory at all at this stage. If you take the left-hand side, if you take ham, that is quite lean, 20% of fat, and the rest is meat. Well, there's a lot of water. The quality of your ham will depend on the amount of water. It's a good quality ham here, but what is interesting is that there's its fraction which we call the active cell mass, which does not include the extracellular water. What is the active cell mass? Well, it goes back to what I was saying about dissipative systems. Everything that is producing energy, basically, it has to do with metabolism, communication, evolution. What is included in the nucleus, storing energy. Basically, it's the definition of the thermodynamic definition of a dissipative system. And you see what I'm getting at, basically, taking into account all these limitations to assess provisions and expenditure in terms of energy. If we look at this from the thermodynamic standpoint, we may have the beginning of a solution to our problem. So the active cell mass is a dissipative system. It is at the center of energy expenditure. There's also supplies and provisions. There's information. There's adaptation. This is a tool we should be able to quantify, to model, to predict, because it has an impact on the prognosis of the nutritional status, and it would probably be much more accurate and useful. The active cell mass in mammals, there's a curvilinear relationship in absolute value expressed in kilos, ratio between expenditure of energy in an organism and the cell mass. It's a ratio between the power of the engine and cylinder capacity. And you see that man, and this may be one of the reasons why man has evolved successfully, is at the bottom of the curve, where you have the better yield, so to speak, whereas an elephant has to eat 200 kilos of fodder to remain alive, and a mouse, this is a big one, is forced to eat twice its weight to survive. So there is a bit of a paradox in the denutrition phase as well, because the curve then will tend to go to the left. The more denutrition there is, and more you're going to spend energy and waste energy. So over time, this will be highly detrimental. What is the impact of an aggression infection on the active cell mass? We don't have much information about that. Ideally, we would need a tool that would enable us to assess this active cell mass. What we know for the time being, and that's all we know, we've started working on models, and they need to be improved. That's one thing. And we also know, and this is the last bullet point on this slide, that well, going back to energy balance, studies going back to 1982 have shown that from 4,000 kilocalories to 8,000 kilocalories, complications may appear, infections, and this will have an impact on the prognosis. There is also the concept of a chronically aggressed patient, and particularly during the first week, we have problems appearing, and they never go back to normal. And if you add up 8,000 calories, and if you add 500 per day, this goes very fast, or even as from 4,000 kilos, well, you are in that range. So there are contradictory results. There are methods which are not appropriate to assess the energy expenditure, and sometimes parenteral nutrition is used, which makes things more complex. There's overnutrition, there's the nature of pathogens, very often Staphylococcus aureus, explaining the presence of an energy deficit or famines in developing countries. So much about the energy deficit, and taking into consideration all these limitations that we have to deal with in trying to assess correctly this, it is probably better to limit rather than try to totally compensate for this energy deficit. Here, the blue arrow shows what ideally we should give to the patient, and more recent studies, and we see that basically everybody is below standard, and the blue bars are overestimated in these studies, particularly those that promote controlled denutrition, Arabi or Eden, for instance. And we are comparing people with a high energy deficit and people who have an even higher energy deficit. So it's very difficult to have a clear idea as to all this. There are limitations with methods that allow you to assess the energy balance, including direct calorimetry in the ICU, suggesting that it's probably reasonable to limit rather than totally compensate for the energy deficit. So we are not really well equipped. And finally, we should probably look at this from a different standpoint and take a more thermodynamic approach of the pathology based on the main physiological functions of living organisms, particularly the active cell mass, and we'll be able, therefore, to do away with having to calculate the energy balance. Thank you very much.
Bien, merci beaucoup, Christophe.
Thank you very much. Christophe, are there questions for Christophe in the room?
Je vais juste, si vous permettez, je vais juste commencer par une première question. En fait, donc.
I'll get the ball rolling with the first question, if I may. If I understood you correctly, energy deficit, the more it goes up, and the more it will go up and up if patients are becoming more and more infected. Don't you think not only we should find an adequate tool, but you think compensating for all the deficit of all these patients, all the patients in the ICU, should be something we should strive for, or not? Because as we see, we have very contradictory results. Don't you think we should try and have a more homogeneous population to get better results. Yes, well, you summed it up very well. The way we are managing all this, we'll never achieve it because we're not in the real world in doing that. And this is why I'm suggesting we look at it from a different standpoint and we adopt new tools. I showed you the concept of distributive systems very quickly, granted, but if we had such a reliable tool enabling us to provide a reliable assessment of the active cell mass, then we would probably be much better off and do something much more reliable. Thank you so much. Just like to draw the attention on one point on which I know we have a relative disagreement about the energy deficit, which is defined here as a difference between, on the one hand, expenditure and provision on the other hand, which does not take into account, as you stated, energy reserves, and particularly the dynamic aspect, namely the endogenous production of glucose, which goes down with time, and another aspect which is more connected to enteral nutrition, namely the delay in the absorption of glucids and lipids, therefore energy sources, through nutrition. You think you're giving X calories to the patient, but you don't really know how many calories he's going to absorb, which makes for an even more complicated picture. Yes, well, I agree with you. And this is exactly why I think we should do away with the concept altogether and take this much, much further than we're doing at the moment. About the energy deficit, a question, if I may. 4,000 calories is something, a figure you reach easily. A patient in the ICU which cannot get parenteral nutrition because we don't want to do this early on, will be immediately in a deficit situation. 4,000 calories is something you will achieve very quickly. Yes, within a few days. Some groups, however, are saying that nutrition should be provided by parenteral nutrition, assisting or supporting enteral nutrition, but I am looking at the consequences myself. In terms of therapy, I don't really know what to do. I'm exactly the same situation as you are. Oh, basically, it only takes 4 or 5 days to be in an energy deficit status. Absolutely, not more. Quite clearly. All this is so unclear that I should add that in the expert group that has published the new formalized recommendations published last year in 2014, some of them are in the room, some of these experts, there wasn't any real consensus. And basically limiting rather than compensating for was the conclusion that was achieved, and it was stated within the first 5 days. But that's all. It's not very clear and not much consensus. Basically, what we're doing is that we provide enteral nutrition if the patient can tolerate it. If he doesn't, we wait. So wait and see therapy for the first 5 days. What I showed you on about the distributive systems with the current tools available to us, we look at metabolism, we're exploring this basically, but the other two columns or pillars, we don't look at these at all. So basically it's terra incognita. Thank you very much, Christophe, for this presentation. You ended up on a perspective note or forward-looking note, but I'd like to know what you feel, because basically we're at a time where indirect calorimetry is not feasible. Equations are not trustworthy, and the goal is to extubate the patient as quickly as possible for him to leave the ICU with an acceptable cell mass. What is the connection or correlation with the protein provision? Because you talked about just energy, but you didn't go into the detail. And how can that work together with early recovery or people sitting on their bed, starting to walk very quickly, moving, getting out of the acute phase as quickly as possible. What should our goal be? Should we focus on proteins? Should we focus on clinical goals, since equations and indirect calorimetry don't work? In terms of measuring the energy, we do have a problem of concept. How are we going to do this assessment? If we had another tool that would enable us to measure another element, such as the active cell mass, that would be a good thing. And that we would make sure that this active cell mass is not self-cannibalizing itself, and that would have an impact on the prognosis. So I'm not depressed. I'm not depressed, but it's clear that the situation is quite bleak at the moment. And FAISY, who's going to tell us about the energy deficit, is the next